I'm Dr. Mike Kinsela. I'm a coastal and marine scientist at the New South Wales Office of Environment and Heritage. And we do research with partners such as the Sydney Institute of Marine Science to better understand coastal and marine environments. Through the SIMS Collaborative, we've been able to set up a user group of Waverider Boy instruments. And this allows us to go out and measure the local wave climates of individual beaches. So although we have deep water Waverider buoys that sit offshore and measure our ocean waves, each individual beach actually has its own wave climate. And understanding the wave conditions at each beach is critical to understanding coastal hazards such as erosion, inundation and waves washing up the beach, and also understanding how beaches change over time. Okay, this is the brand new SIMS Mini Waverider Buoy. So today what we're doing with this Waverider Boy is we're putting it off the Royal National Park here, just south of Sydney. So how this works is we put it in the water, it floats on the surface of the water and it moves up and down as waves pass by. It uses a simple GPS to measure its displacement, and from that we're able to pull out data on wave height, wave period and wave direction, and then compare that with the offshore wave data, and that'll tell us how the waves have changed as they've come into the shallow water environment, and that's really what we're interested in today. The Mini Waverider Boy is a really neat little instrument. It's quite simple, and if we have one of these instruments out off a beach or a rock platform or an area of the coast where we're interested in understanding coastal hazards, we can actually work out, well, what is the local wave climate at that site by building a data set over a few months. And we can then compare it with the offshore wave data and say, okay, this is how the waves change as they arrive at this site, and this site's perhaps exposed to waves from the north or the south and not vice versa. Looking into the future with climate change, if we can understand how the processes work at each individual beach by understanding the waves which control the sediment transport and what the beach, how the beach changes through time, we can then look into the future and say, well, under these forecast conditions for a future climate, what might the beach look like? And that's really critical to understanding how the coastal hazards will change through time and identifying which beaches are at higher risk of coastal hazards than others. So the SIMS collaboration allows us to share instruments between the different partner organisations, and this has been really useful in terms of the nearshore wave measurements, because we're now able to access up to 5 of the Mini Waverider Boys. We've created a pool of instruments within the SIMS collaboration with Office of Environment and Heritage, the Water Research Lab at UNSW and Macquarie University, all putting in their instruments into a shared facility. And what this means is that we can now have multiple wave buoy deployments at different sites. So it's a real strength of the SIMS collaboration to be able to share instruments between the different organisations, and it really helps us to do more research. And that's much more powerful than working alone.